There are occasions when the crew may be required to navigate to a waypoint that is not already stored in the permanent navigation database, for instance, following an air traffic control instruction. In this case, it is possible to create a new waypoint. This can be in one of four formats. The first is the simplest, latitude and longitude. Next is called place bearing and distance. For instance, Sierra Alpha Mike 180/45 means 45 nautical miles range on the 180 magnetic radial from Southampton VOR. There is also place bearing/place bearing. Sierra Alpha Mike 122/Delta Victor Romeo 218 is where the 122 Southampton radial crosses the 218 Dover radial. Note, however, that there is no place distance/place distance facility, as this would result in two possible solutions, and the FMC would not know which one to take. Finally, there are along track waypoints. If the route, for example, is a direct track between Southampton and Dover, then Sierra Alpha Mike 030 means 30 nautical miles along the route after Southampton, and Delta Victor Romeo -030 means 30 nautical miles before Dover. But there is no across-track facility as, again, this is not unique. It could be anywhere along the displaced track, and so is not allowable. These created waypoints are normally put into the temporary nav database and are therefore automatically erased at the end of the flight. As we said earlier, the IRS initial position is inserted using the position initialization page at startup. From this point on, there are no further updates directly to the IRS. However, the FMC position is updated. The first of these updates comes at the start of the takeoff roll. The FMC navigation database contains the position of all runways thresholds in the company's route structure. As the takeoff roll is commenced, the throttles are advanced. A contact on the throttle quadrant is called the takeoff go-around switch, or TOGA switch for short. Operation of the switch automatically updates the FMC position to the takeoff threshold. It is also possible to input a displaced threshold. Suppose that we do not need to use the whole runway length and have decided to take off from 2,300 feet past the threshold. In this case, the pilot inputs a correction factor for the displacement distance, and the new position is automatically calculated by the computer as part of the update. We are now going to look at some typical alert and advisory messages. On most systems, there are around 40 to 50 messages, and they vary in detail from system to system, so you are not required to learn these by heart. This is just to show you some representative ones and to show you how the pilots and the FMC interact. You'll remember that alert messages have the highest priority, and they identify a condition which must be acknowledged and corrected by the crew before further FMC guided flight is advisable, or even possible in some cases. Advisory messages have lower priority and inform the crew of CDU entry errors or system status. Here is a typical alert message. Thrust required. It means that VNAV is engaged. We are past the computed top of descent, and additional thrust is required to maintain the required descent path and speed. Here is another. Runway not applicable for SID. It means that the runway which the pilot has selected is not compatible with the required standard instrument departure. Details of runways and SIDs are stored in the navigation database, and it can pick up these types of mismatch. Similarly, we have the alert message, runway ILS frequency error. The FMS knows which instrument landing system frequency is associated with each runway. If the wrong one is selected, it will pick it up. Another possible message is Unable cruise altitude. This is because the journey is too short for the requested cruise altitude. Suppose the route distance is 210 nautical miles and we select flight level 350. The computer will calculate the distance required for the climb to that level, taking into account weight, ISA deviation and wind. A typical figure would be 105 nautical miles. It also calculates the descent distance, taking into account the same factors. Typically, this might be 110 miles. However, the computer works on a minimum acceptable cruise time of 1 minute, which is usually about 7 miles. This would give us a minimum trip distance of 222 miles. We would therefore get an Unable cruise altitude message. If we then select a lower altitude, it should work. By contrast, we have the advisory message, Max altitude, flight level 390. This is because the aircraft is simply too heavy. We have asked for a cruise altitude greater than the maximum attainable at this weight. Let's now look at a serious alert message, insufficient fuel. We'll put ourselves into a typical situation first, then we'll work out how the FMS has arrived at this conclusion. Finally, we'll work out what we can do about it. Here is a route. We'll say that we don't normally take a more direct path because we have to follow the airways. There is an en route alternate. An alternate near the destination where the weather is bad. And an alternate further away where the weather is within limits when we take off. This is the one we have to nominate. You are here when you get the insufficient fuel message. Firstly, let's work out how the FMS has arrived at this conclusion. It knows where you are, and it is continuously working out the length of the rest of the route. It knows your ground speed, so it can work out the remaining flight time. It knows the present fuel and the fuel consumption rate, so it can work out how much you will have on arrival at the destination. It then compares this estimated fuel on arrival with the minimum reserves. Your first reaction might be to make an immediate en route diversion in order to stay within your fuel reserve minima. However, there may be other courses of action, and the FMS can help us perform these calculations and see whether the figures make these options viable. Firstly, you could ask air traffic control for a more direct routing. They might not be able to give it, but it's worth a try. If they say yes, the FMS can work out the new fuel used and revised fuel on arrival. This may solve your problem. You could also think about choosing a different flight level. Climbing 4,000 feet will probably give you a higher TAS and a better specific air range. If you have a strong headwind, perhaps going 4,000 feet lower might reduce it. In both cases, the FMS can work out the revised fuel and time for you. Also, it may be that since you took off, possibly several hours ago, the weather has changed en route. Maybe the nearer diversion is now within limits. If any of these solutions, or a combination of the three, works, then you can proceed safely and legally to your destination. The FMS is a very capable computer, but you don't follow its instructions blindly. It has various what-if options, which should be used sensibly. It does not replace the need for airmanship and captaincy. Let's summarize this lesson. The first 4 pages in the startup sequence are always the same: identification, position initialization, route and performance initialization. The route is usually entered simply using the operator's flight number. Cost index is determined by dividing aircraft operating costs by fuel costs. The range of values is then put on a sliding scale, which is from 0 to 200 for the Boeing Classic series of FMCs. 0 gives minimum trip fuel and 200 gives minimum flight time. A required time of arrival mode is available in order to arrive on time at some designated waypoint, such as the final approach fix, holding fix, or airport. New waypoints can be created by the pilots using one of the 4 acceptable entry methods. These cannot be entered into the permanent memory. The IRS position is not updated after initial entry. However, the FMS position is first updated on takeoff. Finally, we looked at some typical alert and advisory messages. This concludes the 2 lessons on the FMS.